I am Tyler Pecora. I'm a senior here. I am studying in the biology department, and I'm working in the Ebro lab. So,
speak up a little bit.
Louder. Yeah. Okay. So let's go ahead and raise our hand if we have some form of iPod or MP3 player, anything that plays music. All right, now keep your hand up if you feel like you listen a little bit too loud sometimes. Oh, some people raise their hand after that. Okay. So, 28 million Americans have some form of hearing loss, and of that 28 million Americans, 10 million have received hearing loss from noise-induced activities, either in the workplace or recreational, like listening to iPods. And in another recent study done, about 1 out of every 3 college students will experience some form of hearing loss. So this is a growing problem, and one way we can address this is by investigating flies. Believe it or not, flies hear, and it's so important to them that they actually use it for their mating ritual. They'll play love songs to each other with their wings, and the sound will move through the air, and vibrations will be picked up by their antenna, kind of like a tuning fork. And we like working with flies because ethically we can do a lot more with them, and they're cost effective. But also, they have very similar gene instructions to mammals. For example, there is a gene atonal that is so similar in mammals and in flies that if you take a mammal with a broken atonal gene and replace it early in development with a working fly gene, that mammal will develop with working hearing. Flies can go deaf as well. Deep inside their antenna over here, they have these sensory cells. This is a ciliated dendrite. And in there, they have these dynein arms, which are just protein structures. And we know that if the fly is missing this structure, it will be deaf. But what we don't know is how and why this comes to be. So wouldn't it be great if we had a glowing protein structure that we could follow through development? Fortunately enough, that's what I'm working on. By borrowing jellyfish gene instructions and tagging our gene of interest, we can have a glowing protein structure that we can follow through development. So now you're probably asking yourself, what does this have to do with me listening to my iPod? Well, when we have the glowing gene in place, we can expose the fly to loud volumes, like your iPod or like a factory worker, and we can see what's getting damaged and what's causing the fly to have an inability to hear. So hopefully with my research, we can investigate and understand more human hearing loss, both in a hereditary context, where you're losing your hearing at birth, and in our noise-induced hearing loss, where you're listening to your iPod too loud. But until then, please just turn it down. Thank you.